Ever wake up at anchor, check the battery monitor, and wonder, where did all the power go? Happens to the best of us. The problem usually isn't that too much is running, it's that it's running the wrong way. Most boats are full of silent little energy leaks. Not obvious ones, but sneaky stuff, like a fan pulling double the power it needs, or a charger wasting energy just by being plugged in. It all adds up, especially when off-grid. The good news? Fixing it doesn't take a fancy refit or a stack of new batteries. Just a few smart tweaks and some dead simple gear swaps can double your battery life without cutting back on comfort. These 10 boat mods are easy, affordable, and make a massive difference. Let's get into it. Switching to USB-powered fans and speakers is a no-brainer when it comes to cutting energy use on board. These devices are built to be efficient because they're originally designed to run off internal batteries. That means they sip power compared to traditional built-in fans or stereo systems. A quality USB fan can run all night on just a handful of watts, giving you airflow where you need it without dragging down your batteries. Same goes for portable speakers. Modern Bluetooth models put out decent sound while pulling less power than a fixed marine audio system. Another advantage is flexibility. You can move them around the boat as needed, use them in the cockpit, bring them ashore, or stash them away when not in use. Most charge off a standard USB plug, which means no need for inverters or high-draw AC outlets. For the speaker setup, some even run directly on 12 volts, letting you bypass conversion losses entirely. Altogether, these lightweight gadgets free up your energy budget for more critical systems without sacrificing comfort or sound quality. If you're aiming for longer stays off-grid, cutting back on non-essential loads without losing convenience makes all the difference, and these devices help you do exactly that. Swapping out old incandescent or halogen bulbs for LED lights is one of the easiest and most effective upgrades for any cruising boat. LEDs use up to 80% less power than traditional bulbs, and they last much longer, often for tens of thousands of hours. That means not only do you reduce your daily energy draw, but you also save yourself the hassle of constant replacements. LEDs come in a wide range of formats: strips, pucks, dome lights, reading lamps, and many are dimmable or offer color-changing modes, which can further reduce consumption. They're ideal for both cabin lighting and navigation lights, and newer models are designed to be drop-in replacements, so the install is usually plug-and-play. For night sailing or anchoring, some LED lights even offer red or blue modes to preserve night vision while still giving you enough light to move around. If you're concerned about the draw from interior lights, especially during the darker seasons, upgrading to LEDs means you can keep the boat lit without draining your battery bank. It's one of those upgrades that pays off every single day. You flip the switch, get the light you need, and barely make a dent in your power reserves. Laptops are among the highest power draws on a sailboat, especially if used for editing video, navigation, or remote work. Plugging a laptop charger into the inverter seems simple, but that double conversion, from DC to AC, then back to DC, is terribly inefficient. A much smarter approach is using a DC-DC converter designed specifically to charge your laptop directly from the boat's battery system. These converters take your boat's 12 or 24-volt supply and convert it to the exact voltage and current your laptop needs. They're compact, reliable, and eliminate the need to run the inverter just to charge a single device. Many also support USB-C power delivery, which is a standard for most modern laptops and tablets. The difference in power usage is significant. A direct DC charger can use 30 to 40% less energy than going through the inverter. That means less wear on your batteries, less heat, and more available power for other systems. These converters are also widely available, inexpensive, and easy to install. Just plug into a fused DC line and you're good to go. For anyone who uses their computer frequently aboard, this simple change adds up to major energy savings over time. Connectivity at sea has come a long way, but the hardware that comes with systems like Starlink isn't always optimized for efficiency on a boat. The default Starlink setup relies on mains power, which means running an inverter just to keep it online. That's a huge energy hit, especially if it's running 24/7. A more efficient setup involves two changes. First, power the Starlink system with a DC converter that matches the voltage of your battery bank. These are available online and let you bypass the inverter completely. Second, replace the standard Starlink router with a 12-volt Wi-Fi router. There are plenty of compact models built for vehicles, or RVS, that do the job well. Together, these changes can cut your Starlink system's energy use in half or better. Instead of drawing 80 to 100 watts through the inverter, your new setup might sip just 30 to 40. That adds up quickly, especially if you rely on internet access daily. Optimizing your network gear to run natively on DC power reduces draw, simplifies your system, and avoids the inefficiencies of unnecessary conversion, all without giving up the connection you need. Solar panel performance drops dramatically as temperatures rise. Heat reduces voltage output, and on a boat, panels are often mounted in full sun without much ventilation. To counter this, always install panels with airflow underneath. Even a few inches of open space can help panels shed heat and maintain higher efficiency. Glass panels outperform flexible ones in both power density and lifespan. They resist salt, dust, and UV damage far better, and they don't develop the hazy coating that plagues plastic-surfaced flexible panels. Although they're heavier and a bit more work to mount, they consistently deliver more energy per square foot and hold up longer in harsh marine environments. If deck space is limited, that efficiency boost can make a big difference over time. Higher output means faster charging and less reliance on backup sources like engines or wind generators. When choosing panels, look for high-efficiency monocrystalline models with a solid frame, and be sure they're rated for marine use. Mount them away from direct deck contact, allow for airflow, and clean them regularly. Cool, clean, glass solar panels are the best long-term investment you can make in a dependable, high-output energy system. Refrigeration is one of the biggest continuous power draws aboard any cruising sailboat. A fridge or freezer that runs off an inverter forces you to keep the inverter on all day and night, which means constant, unnecessary power loss. Instead, using a fridge or freezer that runs directly on DC, 12 or 24 volts, significantly cuts your daily energy consumption. DC refrigeration units are specifically designed for off-grid use. They use efficient compressors and insulation to maximize cooling while drawing minimal power. Many can be fine-tuned to balance performance with energy savings. Since they run directly off the battery bank, there's no need for conversion losses, which saves anywhere from 10 to 30% in wasted energy. In hot climates or full-time liveaboard situations, that efficiency really matters. A quality DC fridge/freezer may run constantly, but still leave plenty of power for other systems. And since these units are made for mobile use, they tend to be rugged, reliable, and built to handle the motion and humidity of life at sea. Switching to DC refrigeration is one of the single most impactful upgrades for long-term cruising. It keeps your inverter off, your batteries healthier, and your cold beer actually cold without compromise. Even the best solar panels can't perform under shadow. A single small shadow, cast by a boom, radar post, or even a backstay, can reduce a panel's output by as much as 90%. That's not just a drop in one section either. Because of how most panels are wired, shading just a few cells can cut performance across the entire array. To avoid this, think carefully about placement. Panels should be positioned in areas that get uninterrupted sunlight for the majority of the day. At anchor, consider swinging the boom out of the way or installing it with a quick-release mechanism to reduce obstruction. Adding a bimini top array or adjustable solar arch can also improve exposure throughout changing daylight angles. If possible, wire panels in parallel rather than series, so that one shaded panel doesn't bring down the output of all the others. Using bypass diodes or MPPT controllers can also help minimize the impact of partial shading. Solar is your boat's silent workhorse. Clean, quiet, and maintenance-free. But even the most expensive system won't deliver if it's sitting under a shadow. Eliminating shade is a fast way to unlock the full potential of your solar setup. Leaving your inverter running full-time is one of the most common and costly energy mistakes on board. Even with nothing plugged in, most inverters draw a baseline load just to stay powered up, often 20 to 50 watts continuously. That means you're using energy around the clock for absolutely nothing. The better strategy is to keep the inverter off by default and only switch it on when using high-draw AC appliances like a microwave, induction cooker, or power tools. Everything else, phones, routers, laptops, fans, can usually be powered directly from DC sources or with a DC-DC converter. Think of the inverter like a power-hungry middleman. Anytime you use it, you're converting battery power to AC, and then many devices convert it right back to DC internally. That double conversion eats up efficiency and drains your batteries faster. Some boaters wire their inverter to a switch or remote control so it's easy to activate only when needed. This simple habit reduces daily power consumption, keeps the system cooler, and extends battery life. Inverters are useful tools, but they shouldn't be running in the background all day. Treat them like a tool, not a lifestyle setting. One of the easiest ways to save power on board is to run your gear directly from the battery system. Devices that use 12 or 24-volt DC power bypass the inverter completely, eliminating the energy losses that come from converting DC to AC and back again. The more you run straight from the source, the more efficient your setup becomes. Many boat-friendly appliances and electronics now come in DC versions. Fans, monitors, water pumps, TVs, routers, even some blenders and tools are all available with native DC power support. These are ideal for off-grid setups because they're designed to sip power while still delivering good performance. This approach reduces not just energy use, but also complexity. DC devices don't require bulky adapters, chargers, or voltage regulators if they're correctly matched to your system. Wiring is simpler and often more reliable, especially in a damp marine environment where fewer connections mean fewer failure points. Every time you avoid using the inverter, you're gaining back valuable power. Multiply that over days, weeks, and months at anchor, and it's a major boost to your autonomy. A well-planned DC system runs cooler, quieter, and longer, all without sacrificing comfort or convenience. Charging small electronics like phones, tablets, GPS units, or headlamps through an inverter is a silent power killer. What seems like a minor draw adds up quickly, especially when done daily. USB devices are naturally designed for 5-volt DC power, so feeding them through an inverter is like taking a detour through wasted energy. Instead, install direct USB charging ports throughout the boat. These draw straight from your 12 or 24-volt supply, eliminating the need for conversion. Modern models often include both USB-A and USB-C outputs, and some even feature display readouts to monitor battery voltage. These ports are cheap, easy to install, and can be mounted nearly anywhere, at the nav station, near berths, in the galley, or at the helm. Having multiple charging spots also reduces cable clutter and keeps everyone's gear powered up without constant juggling. The cumulative savings from using direct USB charging are bigger than most realize. It's not just about efficiency, it's about freeing up your inverter for the tasks that really need it, while giving all your small gadgets the power they need without the waste. So there you have it, 10 dead simple upgrades that make a massive difference in how long your battery bank lasts. None of this is about sacrifice or going without. It's about being smart with the power you've already got and squeezing every last bit of efficiency out of your system. The more you can cut out wasted energy, the longer you can stay off-grid, the less fuel you'll burn, and the more freedom you'll feel out on the water. The goal isn't just to save power, it's to make life on board smoother, quieter, and more self-sufficient. Whether you're anchored in a remote bay or tied up for a few days between passages, these little changes add up fast. And best of all, most of them are cheap, easy to install, and work with any setup. If you've got a tip of your own that's made a big impact on your energy use, drop it in the comments. Sharing what works helps all of us out here. Thanks for hanging out, and I'll catch you next time. Cheers!